So first of all, today what we want to talk about again is similar. Similar is two shapes. They have the exact same shape but different sizes. Okay? But we want to specifically talk about similar triangles today. So to be similar triangles, they have to have the exact same shape. And to have the exact same shape, we're going to know a couple of things. One, their corresponding angles are congruent. Okay? So if they're the exact same shape, then the angles that go together will definitely be congruent. That makes sense to me. And the second thing is that their sides are proportional. Okay, what does proportional mean? It means that they're going to have the same scale. Same scale, right? Maybe it's twice as big. So one side to the other side would be twice as big. Another side to the other side would be twice as big. And then the third side to the third side would be twice as big. That's what's going to make it similar. Okay, so let's take a look at graphing triangle ABC. So first of all, get out my ruler. And I'm going to try and draw this in. Okay, here we go. I'm going to graph this on a piece of graph paper. And I'm going to go ahead and start with A at 5, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's A. 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There's B and 2, 8. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Here's my little triangle. I'm going to go ahead and draw it in. Okay? Okay, there it is. Okay, there's triangle ABC. A should probably be more over here, right? B should be more over here, and there's C. Okay, that's easy to see. Okay, so we got it. Now, it says on the exact same graph. Am I going too fast?
Yes.
Okay, no problem. You guys go ahead and catch up, and I'll use some white out to fix my little. Yeah, pen marks. Thanks, Jay. Okay.
Hey. Good.
Okay, so then, on the same set of axes, you ready? Let's do AED. Now, A is the same A, right? So E, let's see, E is going to be at -1, 6. 1, 2, 3, 4, 5, 6. So here's E. And D is going to be at 5, 2. 1, 2, 3, 4, 5, 1, 2. Okay? And there's D. Now, it talks about triangle AED. So I'm going to go ahead and try and draw in another triangle. Okay. So, okay, draw that in, and that in, and then that in. Okay. All right. So far, so good, right? So what I really have is two triangles. I've got my blue triangle. That's my ABC, that's my blue triangle. And I've got my orange triangle, which is the bigger one, okay? Triangle AED, okay? That's my bigger one. But you can definitely see you've got a triangle inside of a triangle, right? Do the two triangles look the same shape?
Yes.
They do, don't they? They really do definitely look the same shape. So here's the thing about math. You can't just say they look the same, because one could be off by just a little bit, right? And you can say, well, it really looks close to me, but what if one line is off by a itty bitty bit amount and you couldn't really tell? So we have to be able to prove that they definitely are the same shape. So the way we're going to do this is with this formula. Okay, there's a formula called, you ready? I want you to write this down. So angle, angle, sim. Okay, and it stands for, ready? Angle, angle, similarity. Okay, write that down. Angle-angle similarity. It's a theorem, And in math, theorem just means it's a math rule. It is a theorem. And again, in math, theorem just means it's a rule. Okay, so here's our rule. I'll say it and then I'll write it. If two angles of one triangle are equal to two angles of another triangle, then obviously what do we know about the third angle? I'll say it again. I'll show the picture. Okay. If two angles of one triangle are equal to two angles of the other triangle, right? Then what would we know about this third angle? They'd have to be the same too, right? Wouldn't that make sense? Just real quickly, don't write this down. Just let me flip the page. Okay. Let me draw two triangles. Watch. Should make a lot of sense, hopefully. Let's say that this angle is 80 and this side was 80. Let's say this angle is 60 and this angle is 60, okay? What do you know about the third angles? What do you know about the third angles?
They must be the same.
They must be the same, right? I mean, so you don't need all three. Because if you have two of the three, then the third would be the same. Everybody agree with that? So you don't need to write angle, angle, angle. You don't have to write angle, angle, angle. Having two is enough because it forces the third, correct? So if two angles of one triangle are congruent, are you writing this down? Are congruent to two angles of another triangle, then the triangles are similar. Not the same, not equal, but similar, meaning the same shape. So if all their angles are equal, they'd have to have the same shape. That makes sense to me. Same angles, right? No matter one's big, one's small, they'd have the same shape. Not the same size, but the same shape, okay? All right? Now that's going to be on your next test. I'm going to say, why are these two triangles? I'm giving you a test question. You guys listening? I would say in a test question, why are the two triangles similar? And you're going to say, yes, they're similar by angle, angle, similarity. And if you want to abbreviate, just go sim. That would be the reason, okay? So let's keep going. So are these two triangles congruent? Well, I think they are not congruent, but similar. I think so. Sure looks like these two triangle angles are equal. I do know for a fact that they both share angle A. You agree with that? So that angle A is equal to angle A. I know one triangle, sure. How do I know about these two triangles? Well, what I'm going to do is this. It says find the slopes of CB and ED. So let's find the slope of CB, okay? So CB, and we're going to do ED. So we're going to do the slopes, okay? I'm going to do the slopes here. So the best way for me to do the slopes is just counting. I know slopes rise over run. So if I count from one to the other, let's see. So ED, let's see, the slope for CB is down 1, 2 over 1, 2, 3, okay? So this would be down 2 over 3, okay? That's the slope. And the slope of ED is down 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6. Down 4 over 6. But if I reduce that, negative 2 over 3, okay? So if the slopes are the same, then the lines are parallel, correct? One of the things we know about parallel lines is it forces this angle to be equal to this angle. They'd have to be if the slopes are the same, right? So we can say that yes, these two triangles are similar, okay? So it says, are the triangles similar? Yes. And we're going to say angle A is congruent to angle A, okay? Okay, angle A is congruent to angle A. They both share angle A, okay? And I'm also going to say that angle, and I'll show this in a minute, angle ACB is congruent to angle AED. And I will bring back my picture and show you what it means, okay? Bring back my picture, okay? Now, they both, if I were to draw them separately and put it So I'm going to say by, I'm sorry, I'm getting ahead of myself, by angle, angle, sim. You got to put that by angle, because that's the theorem, okay? So, they both share angle A, so that means they both have one angle that's equal to each other, because they both share angle A, right? Angle A is an angle for both of them. And they both have this other angle here that's equal. So we can say yes by angle, angle, similarity. Okay? Now there's one more we're going to learn also, and we'll learn that one tomorrow. And that has to do with angle, side angle, similarity. We'll do that tomorrow. Okay? For today, we're going to go ahead. I know we're going to shorten period, so I'm going to stop recording. I'm going to pass out some homework.